Requirements are one of the main deliverables for the business analyst during the systems development lifecycle. However, there are many other deliverables, and we'll begin our exploration of those other deliverables by talking about use cases. After this video, you'll be able to identify appropriate use cases, describe the purpose of creating use cases, as well as describing the major components of a use case. We'll look at several examples. Finally, you'll be able to select the appropriate form of use case for your project. Let's start by looking at how use cases fit into the larger scheme of the systems development lifecycle. We've talked about plan phase, and now we're spending our time in analysis phase. We spent a lot of time talking about requirements, which, like I said, are the primary deliverable of the systems analyst during the analysis phase. There are several other deliverables, however. Those include use cases, as well as process models and data models. We'll explore each of these in its own depth. We'll start by looking at use cases as a form of additional documentation during analysis phase. The purpose of use cases is to validate and improve your requirements. In other words, we write use cases so that we can refine the requirements that we wrote in our earlier step. A secondary purpose of writing use cases is for our testing team. Use cases help the testers understand how the system will be used in the context of its own process. They can then use this to plan their testing of the system to make sure that it meets the requirements. A use case is essentially a case for which someone might use a particular system. We'll look at an example of that in the upcoming slides. We also use a use case diagram to help us organize our use cases. A use case diagram does not describe, for example, the individual steps of a use case. Instead, it describes the relationship of several use cases to each other. A typical use case diagram might include something like this with the stick figures that you see here, as well as ovals containing the names of our use cases. So in this case, we have 3 use cases: to record an offer, evaluate an offer, and take delivery. The salesperson, management, and the customer in this case are all actors in the use case. In other words, they cause action to happen. The use case diagram is kind of like a table of contents or an index into the use cases for our system. Let's now look at what individual use cases might look like. Use cases will vary widely from organization to organization, and unlike requirements, we don't have quite the history of knowledge and standardization on the topic. That being said, use cases are still widely used in various forms for software engineering. In the Agile community, use cases have kind of transformed into a new concept called user stories, which is very closely related in its heritage to use cases. The process for creating use cases begins by identifying the use cases and drawing your use case diagram. Again, the use case diagram is more like a table of contents or an index into all of the use cases that you have. Then you'll dig into each individual use case and identify the major steps. After that, you'll identify the elements within each of those steps, and then finally, it's important that we confirm or validate the use case with our business user to make sure that it lines up with their particular understanding of how events will unfold. In order to identify use cases, we use many of the same methods that we use to elicit requirements. We can review our requirements document. We can also conduct interviews, and if you'll remember the listen article from the earlier lesson, you can also use all of this information to elicit events and responses to those events. These eventually become your use cases. You can extract out of this information the eventual use cases like you see here. So from the interview, we might decide that new vehicles are needed for inventory, and therefore one of the use cases that might come out of that is to take delivery of a new vehicle. Let's now look at the components of individual use cases. The format of use cases, as we'll see, varies widely among organizations. There is no one standard format, but this will give you an idea of some of the things that you might typically see in a use case. Use cases have actors. That's the person performing the act or the use case. In this case, we're looking at an example from the textbook on which this course is based, and you can see that they have an actor here, which is a lawn chemical applicator. This is a person, not a thing or a device that acts in the use case. The description of the use case is a broad overview of what will happen during the use case. A trigger is a kind of event that starts this use case. In some cases, it's just the person wanting, or the actor, wanting to perform some kind of action. But it could also be a particular event that occurs that kind of triggers this use case, so to speak. The use case name should be some sort of functional goal on the part of the user. We'll talk about this concept a little bit more later. But the use case name should essentially start with a verb, and it should be a strong phrase. So in this case, you see, request a chemical. This is a functional goal of the user. Within the detail of the use case, we have steps. And again, depending on what format you use for your organization, the steps might be a very, very long list. I've seen use cases well over 100 pages long. On the other hand, it might be something very, very short. The steps of the use case indicate what steps the actor is performing in each step of the use case. You also have a list of alternative courses. The alternative courses are what happens when you have exceptions. If we think of kind of the primary flow of events as something we call the happy path, in other words, everything goes right, the alternate courses are what happens when something goes wrong. So for example, what happens if our chemical isn't available? Or here you see an example, the quantity available is less than the quantity needed. Then you might take a different set of actions through the system. Exceptions, on the other hand, is events that happen that effectively stop the use case in its tracks. So in this case, we have an example where the chemical that we're requesting is no longer approved for use. And it describes, in this case, the messages that the system might display in this particular case. Conditional steps happen only if certain conditions are true. So here you see in step 1 that the system asks the lawn chemical applicator if he wants the quantity available or to cancel the request. If the LCA asks to take the quantity available, then we do a certain set of steps. If they ask to cancel the request, then you can see this skips down here to 2B and 3B, and those are considered conditional steps that only happen under certain conditions. On the right-hand side of our example use case, you can see the data required for each step in the use case. This helps us know when we get to our data model later and our data design for our system, what data we need to keep track of within our system. Finally, at the bottom of our example use case format, you have a summary. These are the inputs and outputs of the system. This can be used to get a quick summary of the use case and the data needed in order to perform it. And this is useful when designing the system. In addition to all the detailed steps, exceptions, and alternate courses, we might have pre- and post conditions for our use cases. The pre- and post conditions describe things that must be true before the use case can be initiated, or post conditions describe things that will be true after the use case is completed. The preconditions here, you can see the three use cases listed here: authenticate, validate credentials, request a chemical, and pick up chemical. Each one of these might have its own set of preconditions and postconditions for it. The previous use case, or I ask you to consider how the previous use case, the lawn chemical applicator requesting a chemical, might fit into the flow that you see on the screen here. We like to break down our use cases into smaller chunks for a variety of reasons. First, they can get overwhelmingly large to consume. I mentioned I've seen use cases over 100 pages in my career. But there's a more practical reason than simply length and reading convenience, and that is a lot of times we want to reuse our use cases. In a future lesson, we'll look at advanced use cases, and we'll talk about the concept of reuse of some of those use cases, so you can see how that fits in. Going back to our textbook example, you can see how preconditions and postconditions fit into the overall picture of our use case. Now that we've looked at a use case and its components, let's take a look now at use case richness. As I mentioned, use cases and the format of use cases varies widely between organizations. Organizations can have different levels of richness in their use cases, from fully dressed, which are exhaustive use cases numbered with lots of data flows, casual use cases, which might just be a few paragraphs or even a couple of pages, down to just briefs, which are just a few sentences. A brief lays out just the key steps. So, if we were to look at a brief version of our textbook example use case, it might look something like what you see here. Specify the chemical and quantity. If it's not on hand, order more. Otherwise, give the chemical applicator a pickup authorization slip. The level of detail largely depends on the culture of the organization, along with the market that that organization might be operating in. Highly regulated environments like medical devices typically have requirements for exhaustive use cases, fully dressed. On the other hand, organizations that might have a more agile approach might rely on brief use cases like you see here. Let's finish up by looking at some lessons learned and best practices when putting together use cases. First, it's important that the use case describes what the system does and not how the system does it. It is ultimately a logical model of the system itself. This is very similar to what we discussed when talking about requirements. It's important that we include the what and not the how. What this means in practice is that the use case should avoid references to specific technology, such as a button that the user clicks on a screen, or even if the user is using a mobile device versus, for example, a laptop computer or desktop computer. These are implementation details that will ultimately be finally decided in design phase. I mentioned earlier the concept of a functional goal. It's important that the use cases accomplishes something of value from the perspective of the actor or the user. One of the most common examples of something that is kind of widely misinterpreted as a functional goal would be logging into a particular system. A use case for an actor to log into a particular system doesn't necessarily accomplish something of value for the user unless that system happens to be operating in an area where security is ultimately very, very important. And finally, it's important to focus our attention first on the happy path, which is essentially the course of events where everything goes well. And then later we can fill in details as it relates to exceptions. Future lessons will look at use case diagrams in more depth, as well as look at some advanced implementations of use cases. A large systems improvement project could have hundreds, if not thousands, of use cases. And so the question becomes, how do we organize all of this information? Use case diagrams help us organize our use cases and give us kind of a visual index or table of contents into the use cases that we have for our system. In this video, we'll explore use case diagrams, as well as some advanced features of use case diagrams. After the video, you'll be able to describe the role of the use case diagram, as well as define the two major types of use case reuse. Finally, we'll be able to organize use cases using packages after this video. But first, let's talk about the use case diagram itself. The purpose of the use case diagram is to show the relationship among use cases. It is effectively a table of contents, or sometimes you can think of it as an index into the use cases that we have for our system. These use cases may number in the hundreds, or in a large project, even thousands of use cases. Relationships among the use cases can be very complex. There's actually a formal language out there called UML, or the Unified Modeling Language. And use case diagrams are one type of UML. It's a formal syntax for modeling the complexities of relationships that we might have among use cases. We have a number of tools that help us draw use case diagrams. One of the most popular tools out there is something called Microsoft Visio. There are many others, including software from IBM and a company named Rational. You can also find many web-based tools that help you draw use case diagrams. These tools are widely available, and I encourage you to explore them. Within the use case diagram, there are several features that help us kind of organize the relationships among use cases. We'll explore each of these in order. The first type of syntax helps us essentially notate if use cases are related to each other. Sometimes actors are related to each other as well, and use case diagrams provide a syntax for that. Finally, we've already talked about large software projects might have hundreds or even thousands of use cases. There's a concept called packages that help us organize our use case diagrams when we get into large numbers of use cases. But first, let's look at how two use cases might be related to each other. The first type of relationship is called an extends relationship. In the extends relationship, we have a connection between two use cases. The extended use case is triggered under certain conditions. The purpose of this is to add specialized behavior or actions to a base use case. For example, if a student is registering for classes, they may need to register for special classes. Not all of the time, but just some of the time. This is an extends relationship. Also, some courses might have prerequisites. Again, not all courses, but just some courses. This also is a good example of an extends relationship. We might need to, when the student's registering for classes, we might need to identify those prerequisites. If we do, then we would invoke the child use case. If not, then the main use case, in this case register for classes, would just continue under normal circumstances. Another type of relationship between two use cases is called an include relationship. In the include relationship, the include use case is triggered by the base use case under all conditions. So this is something that is required in order to perform the primary use case. The purpose of an include relationship is to simplify the writing of the base use case by carving out a new use case for potentially complex logic. It also allows the specific function that is included to be reused by many different use cases, therefore simplifying your diagram. So in this case, we have a use case for track sales and inventory data. Both the reorder supplies and produce management reports use case make use of this track sales and inventory data. This helps us because it simplifies our diagram, but also if we need to update the track sales and inventory data use case, we only have one use case or one document to update. Note that the include relationship, if you're using Microsoft Visio, might be called a use relationship. They mean the same thing. So use cases can be related to each other via an extend or includes relationship. Now let's take a look at how actors might be related to each other. In this case, we have a patient, which represents a normal patient, and then we have a specialized version of a patient actor called a new patient. The term that we use in this case is inheritance. The new patient effectively inherits the use cases that the patient participates in. In this example, the semantics or the meaning of the diagram is that the create, modify, basic info use case as well as the register new patient use case make use of a new patient actor. The patient actor, on the other hand, participates in the remind patient and schedule change appointment use cases. In this case, the arrow is drawn from the new patient to the patient, indicating that the new patient effectively inherits the traits or characteristics of the patient. This shows that the two actors are related to one another, although they're not quite the same, because we wouldn't, for example, register an existing patient as a new patient, and we might not need to go through the create, modify, basic info process for existing patients. Finally, let's take a look at how we organize a large number of use cases. Use case diagrams provide a syntax or a set of kind of iconography or symbols for organizing use cases into packages. What you see here are packages that look much like file folders with the little tab in the upper left. We then use these as kind of categories of use cases, and then we draw lines from the actor icons to the packages that contain use cases that those actors participate in. If you can imagine use case diagrams being multi-page, the package page might be the top page. That gives you an idea of what is contained in the pages below and where to go to find the use cases that you might be interested in. These lessons give you an overview of use cases and use case diagrams, as well as some advanced features of use cases. As we move ahead in the course, we'll look at other types of analysis phase deliverables, including test cases, prototypes, process models, and data models. Suppose you advertise a new electronic device. This device has an amazing 12-hour battery life. An auditor comes in and says, how do you know that this device actually has a 12-hour battery life? Ideally, you'd be able to say, because we tested it. Test cases are an important part of the system's development lifecycle because they help us know whether or not the system that we built or bought actually meets the requirements that we've laid out during our analysis phase. After this video, you'll be able to describe how test cases fit into the system's development lifecycle. You'll be able to define a test case, as well as describe the key components of a good test case. It's important to understand that software testing is a large and complex discipline in and of itself. You can even get a whole certificate these days in software testing. This video is not meant to replace a formal education or background in software testing, but instead to introduce some of the important concepts and the purpose for developing test cases and testing our system. We are emerging from our discussion of requirements writing in the analysis phase. After we've defined the requirements, we go through several business steps of resolving priorities and inconsistencies and then identifying improvements. After that, however, many people are surprised to learn that developing test cases is actually part of the analysis phase. So after we write requirements, we then write test cases that will help us know whether or not the system that we have yet to build or develop actually meets the requirements that we've written down. Developing test cases is an important part of the systems development lifecycle. Identifying improvements is ultimately a creative process, and this is usually led by the business team. There are several techniques out there for doing this, and this is not meant to be a course on identifying improvements and resolving inconsistencies. But some of the things that we might do are things like problem analysis, root cause analysis, informal benchmarking, as well as technology analysis. Each one of these is a complex discipline in and of itself. But let's return to the last step in our process, which is developing test cases. Test cases are an important part of the systems development lifecycle. According to IEEE standard, a test case is a set of test inputs, execution conditions, and expected results developed for a particular objective. Ron Patton says that test cases are the specific inputs that you'll try and the procedures that you'll follow when you test the software. As part of preparing for this lesson, you are assigned to read an article on writing good test cases. You can see Boris Beiser's definition here. The point is, test cases are a set of specific inputs and instructions to follow when testing the software. When my undergraduate students often write test cases for the first time, the usual mistake is not being specific enough in specifying how to test the software. Test cases are important because they help us understand whether or not our software meets the requirements that we've laid out. So here's just a high-level example of what a test case might look like at its bare minimum, understanding that test cases can be incredibly complex. Here's a sample requirement. The system shall provide a means to store a customer's first name. Simple enough. How would we test this? How would we know, for example, if the system is actually storing the user's first name? Well, our test case would consist of, at a minimum, a set of inputs, in this case the first name Jim, execution conditions such as the system is on the Enter New Customer screen. We have some sort of expected result, so how do we know when this works? And then finally, the definition of a defect. It might seem obvious in a simple test case like this what a defect is, but I can tell you from experience it isn't always obvious. Sometimes deciding in advance what constitutes a defect is a very important part of writing the test case. You can think of it as giving the testing instructions to someone who is unfamiliar with the system. How would they know if things did not work as expected and when to report a defect? One or more test cases are used for each requirement. In effect, the net effect of all the test cases is to combine to prove that a system meets a particular requirement. This proof can be used as evidence that the system is ready for deployment, or in highly regulated industries, the results of your test cases can actually be used to pass an audit. In this case, it's very important that you document the results and are very careful when writing your test cases. That was an example of the simplest possible test case that we can imagine. It's important to understand, though, that test cases can actually become much more complex. Here's an example of a template showing a more complicated test case. You can see at the top we have a set of kind of metadata about the test case, who wrote it, preconditions, dependencies, a list of steps, which could grow quite long, and then a list of postconditions as well. When developing test cases, it's important to specify specific information and specific inputs. It's also important to test for specific holes in the system or omissions. So, for example, we might take the following requirement from our textbook, which is that the system will enable salesperson to create a customer offer. We could develop a number of test cases based on this one requirement. One might be adding a customer offer where the information is complete. We might also try to add a customer offer with a missing address, or a customer offer without a first name. We could also try and add a duplicate customer offer. In this case, it's very important to list a specific set of inputs, as well as agree on what constitutes a defect in advance. You can also think of test cases that might involve security. So, for example, in this case, the requirement says that the system will enable a salesperson to create a customer offer. But what if we try to add a customer offer with complete information using a non-salesperson's account? You can see how very, very quickly one requirement has resulted, in this case, in 5 test cases. In most cases, we can develop many more test cases based on a single requirement. Each should include specific inputs, execution conditions, and an expected result. From Microsoft Excel to HP Quality Center, solutions abound for test case management. Sometimes we keep track of our testing results in something as simple as an Excel spreadsheet. On the other hand, there's very sophisticated software like HP Quality Center that helps us manage our test cases, test runs, and results.